Welcome, it's Miss Skelton here. This video we're going to add a little bit into your notes today, and then we're also going to review for today's quiz. So we're going to do a couple questions from each section of these notes. It's going to help you review the vocabulary, even though we just came back from that long weekend. So let's take a look. Find the page called Vertex, AOS, our axis of symmetry, and quadratic attributes. So this says tables A and B represent two different functions. One is a linear function and one is a quadratic function. And the goal is that we can tell the difference between which one's which. So I see both table A and B have x's, and then it's in function notation, A of x, B of x. Remember, that's just a fancy way to write y. And when we're looking for something linear, I want you to think about it's a line. It's going to have a constant rate. And if something is quadratic, then I know it's going to make a parabola, a U shape. So looking at the first table, the first thing I want you to check, do we have a constant rate? I can tell the x's are just counting by ones, so the x's are. But then I need to check and see, are the y's counting by the same amount? Looks like they are. They're going down by 0.25 each time. So that pattern, since that exists throughout the entire table, tells me that table A is linear. Now table B, I can tell, let's see. At the beginning, it's getting bigger by, what is that, 7.75? But then I can tell, well, it's going to change a little bit here. It's not exactly the same rate. It looks like here it's getting bigger by, 7.25. And then here by 6.75, it's not a constant rate. Let's go ahead and then do this last one. Here it's getting bigger by 6.25. So I'm going to say, since I know that it's not linear, this must be the quadratic one. And what we're going to see today is that quadratic tables, they still have a pattern. So I know it's not increasing by the exact same number, but I want you to look for a pattern in how the table was changing. It was increasing by 7.75, then 7.25. It looks like here all of these changes in our y values, they all differ by the same amount. So it looks like here it was changing by a half less than before, and a half less than before. And so what this is called, what we're going to do a couple of, 0.5 is what I had here. We're going to talk about the first difference. We can tell something's linear if it has a constant rate of change from the very beginning. We can tell a function is quadratic if we look at the first change, the first difference in the table, and see that those are changing by the same thing. And that's called our second difference. So what I'm going to do, we're just going to do the first couple this way. I'm going to go to my calculator. Calculator on. I'm going to y equals. I'm going to put 2x, the first equation. I'm going to go to the table and just copy down the exact numbers from the table. Right? You probably could have done this without a calculator, because the equation is just 2 times each of the x's. And then if this is linear, which we know that it is from its equation, or I could have clicked on the graph button, straight line. So what I'm going to see here is that all the first differences, this is adding 2, adding 2, adding 2 for all of my y values. So I don't need to do a second difference because I saw it had a constant rate of change. Okay, on the second one, I'm going to do 2x squared. So I'm going to go back to my equation and put a squared after the x. So 2x squared. I'm going to go to the table and copy down the numbers that I see as my y values. So I have 18, 8, 2, 0, 2, 8, and 18. And then I'm going to find the difference here. It looks like it subtracted 10 to get from 18 to 8. Remember, you can work backwards. If you do 8 minus 18, it'll tell you the difference. Then here it's subtracting 6, subtracting 2. Then all of a sudden I'm adding, so adding 2, adding 6, adding 10. And then I'm going to check the second difference. So I'm going to look and see how much are these differences changing by. So to get from negative 10 to negative 6, it's adding 4. From negative 6 to negative 2, that would have to add 4 more. Same thing from negative 2 to 2, from 2 to 6, and from 6 to 10. So because the second difference is the same, I know that this is quadratic. Now you might say, Ms. Skelton, what's the point? If you give me the equation, I know if they're linear and quadratic. And you're right. If we have the equation, let's just go ahead and label the next two. It just has an x that's not squared. It looks like y equals mx plus b. So c is linear and d is quadratic because of the x squared. And if you really weren't sure, you could go graph them. Okay, so then let's move on to the next part of the notes. We're going to do about a couple examples from each section, and then I'll go through a few review problems for your quiz. Okay, some of you that got really far on our first day's worksheet, you saw some questions like this that asked you about the symmetry of the parabola. So it says, determine the axis of symmetry. Reminder, it has to start with x equals. It's an equation of a vertical line. And we're trying to find the axis of symmetry for each parabola. So if I tell you that the x-intercepts are 1, 0, and 5, 0, remember those are also called roots. Just throwing in a little bit of quiz review as we go. Let's go plot those. So 1, 0. So on the x-axis, I'm going to positive 1. I'm going to positive 5. And then I know that this is symmetrical. So the axis of symmetry is going to be the x in the exact middle of these 2 points. So since they're 4 apart from each other, it looks like the exact middle here is 1, 2, 3. So the axis of symmetry is going to be x equals 3. Okay, I'm going to go ahead and graph the next one. See if we can do the same thing. The zeros, remember that's another word for root and x-intercept. They're at negative 3 and positive 5. So I'm going to use the same graph. 1, 2. This one I already had. So now I'm looking at these two, and I'm trying to find the exact middle. So if I start counting to where I meet in the middle, 1, 2, 3, it looks like this point that was there before is now going to be directly between negative 3 and positive 5. So that x value is 1. Okay, what if I give you 2 points that are not x-intercepts? So it just says 2 symmetric points on the parabola are negative 7, 2. So I'm going to go, remember it's x, y. So I'm going to go to negative 7 on the x-axis and up 2, and then 0, 2. Okay, this one's a little different. These are 7 apart from each other. So think about what the exact middle would be. Do 7 divided by 2 if you need to. It is 3.5. So directly 3.5 between these 2 points would put me at x equals negative 3.5. So just using the symmetry of the graph to find the axis of symmetry. Well, that sounded redundant, but that's what we're doing. Now let's say that I give you the equation and the axis of symmetry, and it says determine the vertex. So, on something like this, I would still just want you to go to your calculator. So let's go type our equation in y equals. I just rewrote it. It's the same thing. I just changed the f of x to y equals. X squared plus 4x plus 3. There we go. I have it typed. If I go look at the graph, okay, it looks like the middle is at negative 2, just like the problem told me. So if you want, I'll review the calculator steps later before the quiz, but if you know the middle is at negative 2, then just go to the table and look for the value that pairs with negative 2. It's negative 2, negative 1. You'll also know that you found the vertex if you see symmetry around that y value. So if you see the numbers start to repeat on each side, the one in the middle that doesn't repeat is the vertex. So I already knew that this started with a negative 2, and now I found that its y value is negative 1. Okay, we're going to do more problems like this on the quiz review part. I'll review the max and min steps. So if you want to work through these next 2 and check your answer on Canvas, you definitely can. But I'm going to look at the third section. So it says determine another point, take out that s, determine another point on each parabola. The axis of symmetry is x equals 2, and a point on the parabola is 0, 5. Again, I'm going to say let's draw it. So the axis of symmetry, find 2 on the x-axis, and let's draw a vertical line through 2. That's going to be the middle of my parabola. A point on the parabola is 0, 5. So I don't know if it opens up or if it opens down, but it doesn't matter. We can count to the middle, 1, 2, and then count the same distance to the other side. So this point that I just ended up at has an x of 1, 2, 3, of 4, and it has the exact same y value of 5. And that's what I'm looking for. Okay, on B, let's try it. Ooh, it has decimals, your favorite. So B says the vertex is at 0.5, 9. Okay, so let's plot that over 0.5. Ooh, you know what? I'm going to use this graph that I didn't even use up here. So I'm going to go graph the point. The vertex is 0.5 and 9. So I'm going to go over between 0 and 1 and up 9. It should be the next to last line. And then it says an x-intercept is at negative 2.5, 0. So I'm going to go to negative 2.5 on the x-axis. Well, here's the important part. Since I'm given the vertex, I know that the middle of the graph is through the x value of 0.5. So we have to see how close is this x-intercept to the middle, and then I'm going to reflect it to the other side. So I know it's kind of awkward, but I'm going to count from negative 2.5 to negative 1.5. So I've moved over 1, 2. I am 3 units away from the middle. And now I'm going to count 3 units past. 1, 2, 3. And I end up at a 0.5. It looks like 1, 2, 3.5. So just using the middle of the graph to help us reflect a point to the other side, the other x-intercept that we just found was 3.5, 0. Okay, y'all, questions like this will not be on today's quiz. So maybe you're wondering, well, what is on the quiz? I have a couple of review questions. If you want to go back and finish those notes, you can go do the examples yourself and check your answers on Canvas. But here's what you can expect quiz-wise. So a word problem, a fun one. A rocket is launched from the ground and follows a quadratic path modeled by the equation h equals, I'm going to write it over here since it's kind of hard to see, negative 16t squared plus 224t, where h is the rocket's height and t represents time. So first thing you're going to do when you have a word problem is go to your calculator and type in your equation. So use the negative button at the bottom of the screen, 16, and then I have to type x instead of t, my x button, plus 224x. If you go to the graph, it is not helpful because this rocket goes so high. So instead, I want you to go to the table. So second, graph. And now I'm going to scroll down to where the numbers start to make sense. Remember, I only want positive time and positive height. So the first question says, how high is the rocket at 8 seconds? Scroll down to 8 and see what y value it matches with. Mine says 768. We didn't get a unit. So let's go with meters. I would not take off for units on the quiz. Okay, then it says, when does it reach the maximum height? So you're going to have to look at these values and try to find some symmetry. Ooh, it looks like we're close to it right here. 784 does not repeat, but on each side of it, I can see the symmetry starting. So the question said, when does the rocket reach the maximum height? So I need to answer with the x value that goes with it, which is 7. So 7 seconds, and then what is the maximum height? So then I'm looking for that y that I was just on, 784 meters. Feet probably is going to make more sense. Oh, there's the unit, feet. Okay, makes more sense now. And then when does the rocket reach a height of 384 feet? Remember, you need to look for multiple answers here because the rocket is going up. Make sure you're on the x side as you go up. So it looks like at 2 seconds. Oh, I was answering with the number of feet. So 2 seconds. And go look for on the way down. It hits that exact same height at 12 seconds. And then finally, when does the rocket hit the ground? So we want to keep going until the height is 0 again. It looks like it took 14 seconds. So just remember, in your table, your x is representing your time, and your y is representing your height on all these fun word problems. Okay, let's also review the vocab that we've been talking about throughout the video. It says, identify all key features of y equals x squared minus 4x minus 12. First thing I'm going to do, type it in my calculator. So x squared, I know it's hard to see on my screen, but I promise I'm typing the problem on the board. Make sure you're using subtraction signs, unless it's at the very front of the equation when you could use a negative. And then I'm going to go to the graph, and I can see that it opens up, and so it has a lowest point, which would be a minimum. And then to find the vertex, remember we want an entire ordered pair. So this is where we're going to do second and trace. So on your calculator, the blue button, trace, and I'm going to go to minimum. And then when it says left bound, press the left arrow a few times until you can see your cursor. Press enter. When it says right bound, send it to the right. Be patient until you can see your cursor on the right side of the U and press enter. When it says guess, press enter one more time. And my minimum, remember you have to know what it means, it's 1.9999999, so that's really telling me it's at 2 and negative 16. And now that we've talked about symmetry in the table, look what you could go check for. 2, negative 16, and the y values around that start to repeat and show me symmetry. So together, those values are the lowest point, the vertex. The axis of symmetry is the x in the middle of the graph, so x equals 2. And then I can go look for the roots. So remember, on the roots, you can go look at the x-axis. It looks like it crosses at negative 2 and 1, 2, 3, 4, and 6. Remember to check yourself. Those numbers have to have a 0 next to them in the table. Negative 2, 0, and 6, 0. And then the y-intercept, remember that is in the table every single time. It has an x value of 0. Every point on the y-axis does. So that's 0, negative 12. And then domain and range. Please don't miss the domain. Because these graphs continue to the left and right, their domain is all real numbers. Now, that's not true for the range. So remember, we need the lowest value. How low does it go? Well, we found out it goes to negative 16. And because the graph opens up and the lowest it reaches is negative 16, I need that y value, and I need to show that all the y's are greater than or equal to that value, because the graph opens up and all of it is above that lowest minimum. Okay, one final thing to help you for your quiz, and then you will be ready to go. It says, write a quadratic equation in factored form that opens down and has x-intercepts at negative 7, 0, and 5, 0. And then on the board, I have this formula to help you with a question similar. And this is what we did last class. But remember, we said A helps me know if it opens up or down, and then the roots, or the x-intercepts, gets plugged into this equation. So if we're going to write our equation and it needs to open down, I need to use a negative value in the front. So any negative number would work. I'm going to be boring and just put -1. And then the x in the equation, those are the x's in the equation, we're going to go ahead and plug in our roots to this formula. So when the root is -7 and I'm plugging it into a minus, it's going to become a plus. The sign changes because it was minus -7. And then when I plug in a +5, I'm going to see x minus 5 because the formula has subtraction. So you're going to see opposite signs from your roots. From like the roots you were given. And then you can always go and check your answer. So if I think that this is going to be my answer that meets these requirements, I'm going to go to y equals, and I'm going to do -1, and then I'm going to type x plus 7 times x minus 5. I just typed in this equation exactly, and then I can go look at the graph and make sure that it does open down, it has a maximum, and it has the correct x-intercepts. Okay, y'all, so you're going to do a little bit of paper practice. There's a worksheet to complete, and then your quiz. Make sure during the quiz your phones are put completely away. The person next to you will not have the same questions as you, so please don't think that their paper is going to be helpful to you. And then I'll be back for normal tutorials and a normal day starting tomorrow. So y'all, please let me know if you need anything and be on your best behavior. I should have said that at the beginning, and hopefully you've been doing great. All right, see y'all tomorrow.